Alrighty, you two. One for you, one for... Ouch!
What?
Paper cut.
Yeah, they can really hurt.
Just kidding. But to make a point, why do cuts at the surface of the skin hurt so much?
Something to do with receptor cells?
Pain receptors.
Yeah, that's right. That's why it hurts. When tissues are damaged, there are chemicals released. Bradykinin and histamines, serotonin are released, and they stimulate these nerve endings, right, and activates pain signals. Any stimulus that's strong enough could evoke such a response.
So not just a paper cut, but like a pinch too?
Yeah, that's right. Mechanoreceptors, when stimulated by stretching or touch or a pinch, right, the sensations that we feel or that can felt depends on the density of receptors and something called the receptive field.
I think I can sense an investigation coming on.
It's good. Let's see what the two of you can come up with.
So how are we going to test the relationship between the receptive field and different areas of the skin?
Well, we'll have to use the same amount of pressure on the calipers at different distances.
Right, and at different locations too.
Okay, each sensory neuron is sensitive to stimuli within a certain area, called its receptive field. Where the density or number of sensory neurons is high in a certain region of the skin, the receptive field of each neuron is relatively small. These areas would be the most sensitive. The regions with the lowest density then have receptors with the largest receptive fields.
The sensitivity of each region can be determined by whether 1 point or 2 points are felt. By moving the caliper points 5 millimeters closer each time, we repeat the touch test until only 1 point is felt.
We'll do this in different locations. In areas where the density of receptors is low, the 2 points, even with some distance between them, are felt as 1.
That must be because the area is served by only one receptor. The distance at which 2 points are indistinguishable is called the 2-point touch threshold. The areas with the most receptors can distinguish 2 separate touches even when they're very close together.
I guess the index finger is the most sensitive then. It must have the most number of receptors to the smallest receptive fields.
Yeah, that's right. It has the smallest 2-point touch threshold, compared to the back, which is the least sensitive, and has the largest threshold.
That's good. So what does this tell us about the different areas of skin?
Well, not all regions have the same number of receptors.
That's good. Now you're in touch.